Welcome, learners. Today we will write our code in SageMaker Notebook to build our very own machine learning model. SageMaker provides a powerful environment for training and deploying models at scale, and we'll explore its capabilities together. Let's dive in and start creating some magic.
Hello everyone, welcome back. So remember, in our previous video, we have stored our file in S3 bucket. Now what we are going to do, we are going to utilize this SageMaker notebook, our Jupyter notebook, to actually build a model. So this is very important and very key section of this entire project. So be very sincere and careful. So what we need to do first, in order to proceed everything, we have to import some library. So we imported this pandas library. So let us run this command. So we can run it. Now in this section, in this input section, you can see that input command that we need to import a library called Boto3. So this Boto3 library, this is very useful library. It is a Python library and it is very useful when we have to interact with AWS. So what it can do, it can interact with S3 bucket, it can get data from S3 bucket, and it can read, it can write. So very useful. So what we did, we created this section, this code, and here we are specifying the bucket name. First we have to initialize our S3 client. So this is initialization command, and after that we can put the name of bucket, and this is file key. File key means this is a CSV file. So remember, in previous video I demonstrated that we can store a file named bank underscore clean in S3 bucket, but originally the file what we prepared in our data frame in previous videos, I renamed that file, and again then I stored in S3 bucket. So we are just using that file, which name is output.loan.csv. You can use whatever name convention you want in that S3 bucket storing. The main concern is the name of S3 bucket should follow some norm, but this doesn't matter. So what we are doing, we are trying to get this particular file from S3 bucket. Okay, so in order to do that, so there is command. So you can see what it is doing. Object is equal to s3.get underscore object, bucket is equal to bucket name, key is equal to file key. So bucket name we are specifying here, file key we are specifying file here. This is a CSV file which contains our clean data. And then what we are doing, we are creating a new data frame named model underscore data using this pandas library. Read underscore CSV, then object, and then this is a body. So in this way, what we can do, we can start reading this from S3 bucket. So let us run it very quickly. Okay, so I think it is executed, no error. Now once that is done, what we need to do, we need to create some folders in our S3 bucket, so that when we start splitting our data into training set and test set, our data will go over there, and from there when we'll start training our model, we can read it from there. Okay, so for that what we did, we created another folder, a name of folder. We are putting this very conventional formats, this XGBoost as a built-in algo 13. You can name it whatever you want. And then output path we are specifying S3. This is S3 bucket, and this is very standard convention. You can basically go the documentation section, and from there you can see that how it works. So these are two curly bracket, and here you can see that first this represent format means bucket means will be here. This is our name of our bucket, and prefix will be here, and then output. So you'll see that there will be different layers of folders, and finally you will get your output in this output folder. Okay, so let us run this command and see what it provides. So here you can see that this is our, so this is, you can see that we created this S3 bucket, my loan data analysis AI and learn. Then we created another folder named the prefix has been provided here, and in that folders we'll get another subfolder output, and you'll see that our model after training is going to store in this output folder. Okay, so before starting our model training, let us see how our model looks like. So this is a very standard command to see a few 5 lines of rows in our data frame. So let us run it so that we can make sure that whatever data we stored, it's very clean, and our notebook can access, whether it is having ability to access or not, because now we are doing everything from S3 bucket. Remember, in our previous video where we utilize our Anaconda environment and use our Jupyter notebook, we are taking everything from our local machine, but here we are taking everything from our S3 bucket. So let us run it without any delay. So see here the beauty of this data, that we are getting everything. Whatever we have shown in Anaconda environment and SageMaker environment also, we are getting everything. Okay, data looks very clean, nice. And now we'll start working on the splitting of the data. Remember when I demonstrated in model training section using our Anaconda and Jupyter notebook, we splitted our data into two parts: training and test. So this train and test data, it's train sometimes like 80 to 20 ratio train is to test, and sometimes this ratio train is to test is 7 to 30. It depends, but 80 to 20 mostly preferred. Now there is a command to splitting that data in that ratio. So mostly in case of SageMaker, what we do, we use this command. You can use that command as well. You can make it a little more complex, doesn't matter, but this is most standard command: train data underscore test data np.split model. This is your data frame name, sample frac1 random state 1729. And this is basically what we are doing. We are just taking the length of our this data. So remember, it was somewhere around 270 or so after cleaning, so it will split it in that ratio. And then we can examine the shape of our data. Shape means that it will tell how many rows, how many column, and then we'll start working towards our model. So let us quickly run this command. Okay, perfect. So here you can see this lines of code was very effective, and it splitted our data in two parts. So our training set, it contains 217 rows, and our test set contains 55 rows and 21 number of columns in our data set. Okay, now what we can do next thing is we have to train our model. So that is very important section. So I'll take separate video for training our model. Okay, thank you.